Let's look at question 24, and the question reads, a two-digit number is such that the sum of its digits is 13. When the digits are interchanged, the original number is increased by 9. Find the original number. So we have been told that there's a two-digit number, and the sum of the digits making up that number is 13. We are told that when the digits are interchanged, the original number increases by 9. So you have been told to get the original number. Then what are you supposed to do? Of course, let me give you a good example. You can literally be able to understand that this two-digit number can be, for example, xy. Of course, a two-digit number is a number that is actually able to get made up of two digits. Let me give an example of 86. If I say 86 is my two-digit number, then I'll realize that this number, which is 86, has two digits. The first digit is 8 and the second digit is 6. So x is 8 and y is 6. So this is an example of a two-digit number that is actually made up of two digits, that is 8 and 6. So you've been told that the sum of those digits making up that number is 13. So I can decide to come and say x plus y. The first digit is x and our second digit is y. If I add these two digits, the sum must give me 13. I have formed the first simultaneous equation. Look at that. So don't focus so much on 8 and 6 because a sum of 8 and 6 can give us 13. So just pick these two as an example to clearly show us how a two-digit number looks like. And they're actually proceeding ahead and telling us that when the digits are interchanged, the original number increases by 9. So let me say the original number is xy. Look at that. But now the final number after interchanging the digits should actually give us yx. So the digits are x and y. Their sum, that means when you add them together, they should actually give you a sum of 13. And that clearly gives us the first simultaneous equation. And we can take the original number to have digits xy in that order. But when you do the interchanging of those digits, you can end up having a final number with yx as the arrangement of those digits in that order. So we are told that when you do the interchanging, the original number increases by 9. That means this original number has to increase when the digits are interchanged. So we can be able to say yx can be our final number, then our original number is xy. That difference should give us 9. That means when the digits are interchanged, the number increases by 9. That means the difference between the final number after interchanging the digits and the original number before interchanging the digits is 9. But now we're talking about the value in terms of the total value. If I come here, I can decide to take this as ones and this as tens. Look at that. Because of the value, which is 9, we can actually identify the place values of those digits in that number and in that other number. So ones, then tens. So if this is tens, we can say 10 times y plus, we want to get the value of that number. Okay, x times 1. When you say minus, then you can come here and say ones, then tens. Then you say 10 times x plus y times 1. The difference must give us 9. 10 times y, that is 10y, plus x times 1, that is x. Okay, then you can say less, you can open the brackets. 10 times x, because this is an expression, you should actually put it in brackets. Then y times 1 is y. The difference is 9. So we shall have 10y plus x. This negative will affect everything inside the bracket. We shall have less 10x less y. The answer must be 9. Let's collect the like terms. We shall have 10y, okay, less y. So 10y less y. Then we shall say plus this one here, okay, x less 10x is equals to 9. So we'll have 9y less 9x, the answer is 9. We have a common divisor. We can divide all through by 9. You can say divide by 9, divide by 9, just to make it more simpler. So you can have this and this and that, and that and that. So you shall have y less x is equals to 1. That can be our second simultaneous equation. Okay, let's come back to our first simultaneous equation here. Let's write it down. X plus y is equals to 13. Then our second is going to be y less x is equals to 1. Those are two simultaneous equations. And we want to make our work easy. How? We'll actually come here and rearrange this so that they are all y and xx. So we shall say y plus x is equals to 13. Then y minus x is equals to 1. We solve this simultaneously using either the elimination method or the substitution method. We can use elimination for this matter. Y minus y is 0. Then we are actually subtracting. Y minus y is 0. X minus minus x, that will be 2x. Should give us 13 minus 1, that is 12. Divide by 2, divide by 2. So this and this will disappear. So our x is 6. Once we've gotten our x as 6, we shall go back to any of these two equations. We pick one. We shall say, for example, x plus y, this one here. You can even pick this, no problem. Any of them. X plus y is equals to 13, but our x is 6. So we shall say 6 plus y is equals to 13. We shall take 6 on this other side, so we shall have y is equals to 13 less 6, so that our y becomes 7. The number, we've been told the original number is xy. So our x is 6 and our y is 7. So the number is 67. Thank you, and you're most welcome.